Space exploration has rapidly advanced, reaching new heights with cutting-edge technologies like the James Webb Space Telescope and the Hubble Space Telescope. These remarkable tools enable scientists to delve deep into the mysteries of our galaxy. In recent development, the sharp eyes of a young astronomer spotted a massive object zooming through our solar system. They promptly reported the sighting, and with the help of the Hubble Space Telescope, expert scientists and astronomers have now officially confirmed the discovery. There is indeed a mystery object making its way through our solar system. Where did this mystery object come from? Are we in danger? Let's get to the details. The mystery massive object. On August 29, 2019, a young astronomer named Gennady Borisov discovered something exciting with a telescope. He made himself at his Margo Observatory in Crimea. When Borisov first laid eyes on it, the comet was about 3 astronomical units from the Sun and 3.7 astronomical units from Earth. He noticed a moving object in his telescope's frame on August 29th, moving in a slightly different direction from regular asteroids. Borisov got curious, measured its coordinates, checked a database, and discovered it was a new object. Feeling a bit worried about what he stumbled upon, he urgently calculated the near-Earth object rating, and it turned out to be 100%, meaning it was potentially dangerous. In a bit of a panic, he quickly shared the details online to confirm if this was a threat. It took a few weeks to determine that this mysterious comet was an outsider to our solar system. Initially, experts thought it might be a comet close to Earth, just 1.4 astronomical units away from the Sun, following an oval path that takes less than a year to complete. But after watching it 151 times in 12 days, NASA's Jet Propulsion Laboratory's scout suggested that the comet's path ranged between 2.9 and 4.5 astronomical units. Still, there were doubts, because the observations happened when the Sun was pretty far away, making the data tricky. To understand why the comet was taking such an unusual route, experts tossed around ideas, considering strong forces at play. One idea suggested an oval path with a stretchiness factor of about 1, the closest approach to Earth of 0.34 astronomical units, and a point nearest to the Sun at 0.90 astronomical units around December 30, 2019. But on closer inspection, it seemed the path could only be oval if forces other than gravity, maybe gases, influenced it more than other comets they'd seen before. After some digging, they discovered that the comet's path was incredibly unusual, confirming that it was an outsider. The forces guiding this comet couldn't be explained by the usual stuff seen in other comets in our solar system. Where is this comet from? The comet, named 2I Borisov after its discoverer, has intrigued scientists, and they wonder where it is from. Though there could be other kinds of stars, researchers suggest that this comet might have formed around a red dwarf, a smaller, fainter type of star compared to our Sun. Another theory proposes that 2I Borisov could be a fragment of a small planet rich in carbon monoxide. Comets, commonly described as icy, dusty, and frozen gas snowballs, are roughly the size of a small town when inactive. However, when heated by the Sun, their tails can stretch for millions of miles, measuring approximately 9 football fields in length or 0.98 kilometers. 2I Borisov has recently been studied, and the latest discoveries about its composition have been published in Nature Astronomy. Comets, like 2I Borisov, originate from the early material disk surrounding a developing star, preserving clues about the distant past of planetary systems. These celestial wanderers offer insights into the elements that contributed to the formation of Earth and other planets in our solar neighborhood, including water. What makes 2I Borisov even more fascinating is its status as an interstellar comet, a messenger carrying chemical information from a distant star system. In 2019, NASA's Hubble Space Telescope captured images of the speeding comet, revealing a bright nucleus. However, the nucleus itself was too small for Hubble to observe directly. Subsequent Hubble observations in March 2020 unveiled a surprising change in 2I Borisov's appearance. Instead of a single bright core, the images hinted at a portion breaking away from the nucleus. Scientists remain vigilant, using Hubble to monitor the comet's trajectory. The global community, including amateur and expert astronomers, collaborated to trace 2I Borisov's path and confirm its extrasolar origin. Using Hubble, scientist Bodowitz and colleagues observed 2I Borisov between December 11, 2019 and January 13, 2020. Additionally, an international team observed the comet using ALMA, a network of radio telescopes in Chile, between December 15 and 16, 2019. Radio telescopes are essential for detecting low-energy gas in comets. The high carbon monoxide to water ratio in 2I Borisov suggests its origin in an icy region comparable to the Kuiper Belt, where Pluto resides. One theory proposed by the Hubble team suggests that 2I Borisov might have originated from a red dwarf, the most common type of star in the Milky Way. Red dwarfs, being smaller and less bright than the Sun, have colder planet-forming material, ideal for creating comets with characteristics similar to 2I Borisov. Alternatively, the ALMA team speculates that 2I Borisov could be a fragment of a dwarf planet rich in carbon monoxide. Regardless of its origin, 2I Borisov presents new challenges to cometary research. The comet, located much farther than the Kuiper Belt, where Pluto is, challenges our understanding of comets' usual origins. Most comets are thought to have originated closer to the Sun, but were pushed farther by the gravitational forces of Saturn and Jupiter. Some may even have been launched away from the Sun toward other stars. Hubble researchers hypothesize that 2I Borisov may have been directed toward our solar system by a giant planet in a red dwarf system. The ALMA team agrees, suggesting that the comet was likely propelled by a young, moving planet. 2I Borisov, with its high carbon monoxide content, could be a comet or a dwarf planet fragment. The comet's rapid departure from our solar system, influenced by the Sun's gravity, prevents it from being captured in orbit. Despite being born in a different star system, 2I Borisov shares some similarities with comets from our solar system. While the specifics of its surface remain unknown, it has developed a coma, a cloud of gas and dust surrounding the nucleus. The coma forms when solar energy heats the comet, causing ice to vaporize and dust to be released into space. Researchers, including David Jewett from the University of California, Los Angeles, used Hubble to obtain accurate measurements of 2I Borisov's nucleus, estimating it to be considerably smaller than initially thought, almost 15 times smaller, with a radius not exceeding 500 meters. This revelation is significant for estimating such objects' total number and mass in our galaxy and the solar system. Comet Borisov, now drifting away from our Sun, will eventually re-enter interstellar space, never to return. The Sun's gravity influences its trajectory, but its high velocity prevents it from being captured in orbit. As an interstellar visitor, Borisov may be either younger or older than our 4.5 billion-year-old solar system. While comets like Borisov have typically been expelled from our solar system due to gravitational interactions with Jupiter, their specific origin remains uncertain. The comet's coma, a dust-filled cloud, distinguishes it from smaller objects lacking sufficient material or mass to maintain their atmosphere. Despite the mysterious surrounding 2I Borisov, it offers a unique opportunity for scientists to broaden their understanding of comets, especially those from interstellar space. The nature of this comet. Early estimates of the comet's nucleus size ranged from 1.4 to 16 kilometers. What makes 2I Borisov different from comets in our solar system? Because it shrank as it flew by, shedding at least 0.4% of its mass before getting close to the Sun. Interestingly, the speed-up that wasn't due to gravity, puts a cap of 0.4 kilometers on the nucleus size, matching up with what the Hubble Space Telescope suggested before, about 0.5 kilometers. The comet's far-off visit to Earth, over 300 million kilometers away, makes it tough to use radar to directly figure out its size and shape. The backup plan of using the comet passing in front of a star for info is tricky to predict, so it requires nailing down the orbit and setting up a network of small telescopes for a successful observation. Checking out its spin, the Hubble telescope could not spot any changes in brightness over time, hinting that it spins pretty slow, maybe more than 10 hours. But another study using CSA's NEOSat thinks it takes a much longer 13.2 days to complete a rotation, which seems kind of odd. Simulations based on its orbit suggest that the tilt of 2I Borisov might be around 59 or 90 degrees, with the latter being the favorite in the most recent observations. In terms of what it's made of and how it's put together, Dave Jewett and Jane Liu guess, based on how much stuff is coming out of it, that the comet is making 2 kilograms of dust every second and losing 60 kilograms of water each second. They think it got active around June 2019, about 4 to 5 times as far from the Sun as the Earth is. Older pictures show signs of activity between December 13, 2018 and November 24, 2018. What's in 2I Borisov is slightly different but not strange compared to comets in our solar system. It's got less water and diatomic carbon but more carbon monoxide and amines. The amount of carbon monoxide compared to water in its tail, ranging from 35% to 105%, is like another weird blue-tailed comet and is way off from the average of 4% for solar system comets. The comet also released some neutral nickel, which scientists think comes from some unknown nickel compound. The ratio of nickel to iron is like what we see in comets from our solar system. The path 2I Borisov is taking adds to its mystery. It's coming from the Cassiopeia area near Perseus, hinting that it's from the galactic plane rather than the outer parts of our galaxy. It's set to leave the solar system headed toward Telescopium, and it'll take about 9,000 years to travel 1 light-year relative to the Sun in the big space between stars. Is this the first comet to visit our solar system? 2I Borisov is not the first comet to venture into our solar system. Before its arrival, another interstellar visitor, officially known as Oumuamua, was discovered in 2017. These celestial wanderers from beyond our solar system provide scientists valuable opportunities to explore and compare objects originating in different star systems. Each discovery contributes to our growing understanding of the diversity and characteristics of interstellar objects making their way through the cosmos. Where is 2I Borisov now? Scientists last checked out comet 2I Borisov in July 2020, 7 months after its closest point to the Sun. What's cool is that they started watching it when it was on its way into our solar system, unlike another interstellar visitor called Oumuamua, which they spotted as it was leaving. They could only watch that one for 80 days before it went too far. Now, because 2I Borisov swung by us around the end of the year, near the holidays, and scientists could keep an eye on it for a longer time, some folks call it a Christmas comet. They used the Hubble Space Telescope to observe it, starting on October 12th, when the comet moved far enough from the Sun. Hubble is awesome because it's not as affected by the fuzziness around the comet as telescopes on the ground, and this helps scientists study how the comet spins. By doing this, they can figure out how big it is and what shape it might be. What are your thoughts about 2I Borisov? Let's hear from you in the comment section. Also, like this video and subscribe to this channel for more. See you soon.